In the previous segment, we discussed further aspects of TBI involving Ku and contra-Ku features and neuronal shearing. We also reviewed the importance of analyzing TBI from a network perspective and how it can assist in choosing training locations. Now, I'd like to review some social and secondary aspects of TBI in more detail. Until recently, the widespread issue of TBI was greatly underestimated. Recent research has clearly shown how far-reaching the problem is. The actual indirect estimated economic cost of TBI is around $64 billion. This includes lost work hours and the consequences of its impact on social dimensions such as marriage, education, and child development. Part of the problem with estimating TBI incidence is related to measurement of TBI. Rating a phenomena such as TBI is very tricky because of the complexity of the human brain. Beside the standard Glasgow Coma scale used in most hospitals, measures of amnesia and loss of consciousness are also important for a comprehensive assessment. Mild to moderate cases benefit from further neurocognitive testing and monitoring, as subtle losses in short-term, working, or sequential memory may be overlooked but undermine client performance. The primary injury is usually treated by most medical professionals as mechanical damage. 28% are usually a result of falls, especially among the elderly. As much as 20% are due to traffic accidents, while 19% result from other accidents such as in occupational settings. Assaults account for only 11%. When interviewing clients, it is important to review all potential sources of TBI, as they tend to discount moderate-level auto accidents, childhood events, or sports injuries. Recently, TBI has come to be recognized as more than a single physical event. In trying to determine neuroprotective strategies for dealing with TBI, researchers have come to realize that it can induce secondary biochemical changes that continue to have an enduring effect on those affected. Most strategies, such as supplements and other strategies, to date have not been shown to be especially effective. The initial insult leads to an oxidative stress pattern leading to chronic inflammatory activity. This can be either mild or severe in nature. When severe, it can lead to mild cognitive impairment and even early dementia. Therefore, TBI must not be considered an acute or static disorder, but a complex and chronic neurodegenerative condition. The secondary consequences of this often neurodegenerative aspect of TBI paves the way for secondary pathophysiological cascades that include biochemical, metabolic, and physiological changes such as spreading depression, ionic imbalance, release of excitatory neurotransmitters, mitochondrial dysfunction, and activation of inflammatory and immune processes, among others. Some of the more important secondary injury mechanisms involve activation of neuronal cell death pathways or necrosis, microglial and astrocyte degradation, neurotoxicity from excess glutamate and nitric oxide, excess free radical production, lipid peroxidation, and chronic inflammation following trauma, providing a mechanistic link between acute and chronic neurodegeneration. It is important to keep in mind that in spite of all the potential consequences, many individuals do recover well from trauma because of multiple backup networks present in the brain. The amount of resources available appears to vary considerably from individual to individual. This additionally makes predictions about level of recovery very difficult. Another complicating aspect to TBI is the emotional trauma. Post-traumatic stress can result in many of the same symptoms as mechanical damage, including memory loss and general cognitive deficits. Typically, the more severe post-traumatic stress results from severe TBI. Teasing out the effects of each can be impossible at times. Using fast-wave training to reduce slow-wave activity, enhance cortical stability, and increase resilience is typically the first step, followed by slow-wave alpha-theta training in order to integrate trauma. The ability of neurofeedback to accomplish these objectives on a fairly consistent basis makes it one of the best interventions for TBI. Recent research clearly demonstrates neurofeedback's ability to alter structure and function of both gray matter and white matter.